Welcome to the Coffee and Code series, where we discuss software development best practices. Today, we will discuss a crucial topic for any software project: solid design principles. We will discuss how we can use solid principles to develop reliable and scalable software. To discuss this topic, I've invited my colleague Pritam. Pritam is one of our technical consultants at Perituza. He has over 12 years of experience in development, specializing in Microsoft.NET and React. Welcome, Pritam.
Thanks for having me, Asanka. I'm excited to be here.
Now, one of the complaints I occasionally hear from potential clients is that whenever the dev team releases new features, they break existing functionalities. Now, this can be very frustrating to the client, right? And also can cause them to lose faith in the quality of the software. Whenever existing functionalities are broken, that results in delayed deployments, rework, retesting. Now that adds unnecessary cost and time to the project.
I can completely understand how it impacts the clients. Not only budget point of view, but also client will lose their trust in the development team.
It would be inevitable. A couple of weeks ago, I met a gentleman who owns a construction company in Orlando. He came to our booth at a trade show. He has a software project they developed in-house and has been running in production for over 2 years now. However, they started onboarding additional developers recently, and he noticed a significant uptick in quality-related issues.
And there's a lot more to the story than that. For example, requirements documentation and QA process. However, one of the key ways to mitigate the quality issues is through the usage of the solid design principles. It's a part of overall software development standards. If you are expected to have a robust software that is extendable and reliable, then the dev team should follow the solid principles. It's not that hard to follow when you start using them.
Pritam, to start off, can you explain to us briefly what the solid principles are?
SOLID is an acronym that represents 5 design principles for writing well-structured and maintainable code. SOLID principles are fundamental to create clean, maintainable, and scalable software. Each letter in SOLID stands for a specific principle. So let's get first single responsibility principle, open-close principle, then third discourse substitution principle, interface aggregation principle. Last but not least, it's a dependency inversion principle.
Now, these principles have been around for a long time. Even when I was back in college, I spent many a day learning about SOLID. But still, we onboard occasionally to projects that have been built without the use of SOLID. Why do you think that is?
There's the perceived cost of development because it takes more time to develop the features upfront when you use the solid principles. And every company has a different approach to development. If you haven't spent your career in an environment with strong guardrails around architecture and code quality, it can be difficult to implement those practices later on.
Yeah, I can understand. However, from the customer's perspective, they have a budget and a timeline that they have to release their software. Most of the time, those timelines are driven by external factors such as regulatory requirements.
And that's where it falls upon us as the consultant to communicate the value of well-designed software, which will ultimately reduce the long-term development cost. Also, I think to hit the deadlines, sometimes developers overlook the best practices and focus solely on the feature development. And this can make sense in the moment, especially when a delayed release will impact the bottom line. However, unless you actually make up for the technical debt you have incurred, you will ultimately end up with software that's much harder to maintain.
I completely agree with you, because at the end of the day, what matters is that the customer will be successful not just now, but in the long run. Now, Pritam, let's go back to those 5 principles and explain each one of them and their significance.
Sure, Asanka. So let's start with the single responsibility principle, or SRP. This states that a class should have a single responsibility or job.
Now that makes code easier to understand and to extend because changes in one area won't affect the other, right?
You got it. So let's look at the code snippet. Okay. So on a screen, we have an interface of iEmployee, which having the add employee, remove employee, and the save to file operations. But save to file operations is nothing to do with the file operations with the employee data. So let's look at how we can improve this code with the help of the SRP. On the other side, you can see it. I have defined the add operations and the remove employee operation in the separate interface and the I operation in the separate interface.
This is actually a perfect example to explain SRP. Now, when we can extend these file operations without having to worry about the functionalities of employee class.
Exactly. Now, let's move on to the open close principle or OCP. It encourages classes to be open for extension but closed for modification. In other words, altering existing code and adding new functionality, you can do it. It promotes the code reusability and stability.
Now, what this essentially is saying is that you can extend the new functionality without breaking what we have developed previously.
Yes, exactly. Let's look at the code and see how it works. Okay. In the left side, you can see we have the object of employee details with the properties, name, level, working hours, and having the salary calculator function, which calculates the salary of employee, which doesn't have anything. But if you get the scenario and get the requirement from the client that we have to calculate the salary as per the designations, then what we have to do, we have to make changes to the existing code only. That's why it's the functionality of the OCP.
Now I can see on the left-hand side with the salary calculator, the whole calculation is done within one function, right? Now I can see the risk of it. Now with OCP on the right-hand side, I can see we have divided into two different classes and implemented those specific calculations there, right?
Exactly. Now let's move on to the third principle, the cost substitution principle or LSP. This states that objects of derived class should be substitutable for the objects of base class without affecting the program correctness.
In other words, subclass should be able to extend the functionality.
Absolutely. Let's look at the code how we can implement it. On the screen, you can see that we have the car class which having the drive method and another class which is truck which implementing the car and overriding the drive method. That's all at the functionality of LSP.
Now I can see on the right hand side you have implemented an interface and two classes implementing the interface with drive method. Now we have the ability to implement two different functionalities for the drive method within those two classes.
Exactly. Now let's move to the interface segregation principle or ISP. It encourages smaller, more specific interfaces, making code more adaptable and avoiding the fat interfaces, which creates unnecessary dependencies.
So basically it says we should break the code into small interfaces where we can manage them easily.
Yeah, that's correct. Let's look at the code how we can implement the ISP. On the screen, you can see that we have the print task interface which having three different operations. When you implement the interface to the class, we need to implement each and every method regardless of we need it or not.
Yeah, I can see on the right you have created three separate interfaces. Now the developer can implement them as they wish.
Yeah, and that helps to maintain a clean code.
And last but not least, we have the dependency inversion principle or DIP.
Yes, DIP promotes loose coupling by ensuring high-level modules that don't depend on low-level modules directly, but instead depends on the abstraction. This allows easier changes, testing, and the substitution of components.
So that helps developers to develop unit test code.
Exactly.
Now, Pritam, how can we explain DIP easily?
I can explain this with a sample code. As you can see on the screen, we have two classes which having the data access layer, which having the save method. And that method we are calling from the business logic layer. And that's what is the logic of DIP.
Now I can see on the right you have created an interface which we can use to inject and override the method. This is a great example to showcase how we can implement testable code.
Yeah, that's right.
Now, Pritam, as we wrap up, what advice would you give to developers who are looking to apply solid design principles in their projects?
Applying solid design principles involves conscious design choices. Developers should analyze their code, refactor when necessary. It's about writing clean, maintainable code and improve it continuously.
Also, by utilizing solid principles, you can create a robust software that can support large workloads in production while being an enjoyable project for developers. It's a win-win for all. Now, Pritam, thank you so much for joining me today to discuss this very important topic of building robust software with solid principles. I enjoyed our discussion.
I enjoyed it too, Asanka, and thank you for the opportunity to join this discussion.
Now, for our viewers, thank you so much for joining. We will be back with more tech topics soon. Until then, keep coding.